Hi everyone, today we're going to be looking at the Rock Crusher Plant EasyPLC Bricks Do More. Now, a rock crusher or jaw crushers are also known as rock breakers and are used to break up larger, harder materials into more manageable pieces. The EasyPLC Simulator Rock Crusher Plant will show you how you can control this process through a programmable logic controller. We will be using a Do More technology to control this plant automation. Using the 5 steps for PLC program development, we will discuss and show you how to program this rock crusher plant. An Automation Direct Bricks or BRX Do More PLC will be used for this application, but the general methods can be used for just about any PLC in the market. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in the series as well. So the first step is to define the task so step 1 is on a rock crusher plant. So what we do is we'll go to our machine simulator in EasyPLC. We can hit start or go to the machines on the home screen up here. We will go down to where we see the rock crusher plant, which is right here. And once we click on it, this will actually tell us exactly what we have to do over to the left-hand side. It basically says, feed the crusher 1 with large stone blocks. Use a separator to filter the small rocks that need to be set into the reject container via the conveyor belt, and feed the second crusher with the crushed rocks from crusher 1, and then load the transport boxes with the crushed rocks. Using the weighing system, each box weighs 5 kilograms. When the weight reaches 10 kilograms, close the crusher and release the box. So very general and vague description, so we'll have to expand on that a little bit more. So let's just take a look, and under there we also have a demo mode that will help us define exactly what has to happen on our task. So we hit the demo mode. This will bring up the rock crusher plant and actually start operating it for us so we can see exactly what we need to do with this controller. So it'll just take a second here. And there we go. So there's our demo. We can see our demo mode located right here. And you can see our boxes here are being rotated around this conveyor system. We have rock crusher right here that goes in, crushes the rocks. It'll come on to the separator here for some of the other rocks, and then load up into the box right over here into our weigh scale. We can view the I/O and we can see exactly what's happening. All of the digital outputs here, which will allow us to open and close and turn on and off these flappers, come from here. And then our inputs are the detection of what we actually have. So here's our sensors on each one of our corners of our conveyor belts. We can look at the analog in. Right now we're at 9.5. It reached 10, so it released the box and went down to the corner. And we have another one loaded up onto our weigh scale. Using these 3 icons here, we can actually go and fly around this area or actually move around this environment and actually see what's actually happening. So here we'll zoom in, and you can see here's my weigh scale, and you can see my reading and my reading up here. We'll back off, and we can see here we have another. Go to the other side, and you'll see that we have our main rocks being delivered this way over top and down into our first rock crusher right here. And there are flaps going into this bin here of the reject after our separator. The larger ones will then move on to where we can actually crush them again and weigh them. So that is what we have to do into our rock crusher. Now, figuring out the next step, or defining our inputs and outputs, is step number 2 for our rock crusher plant. And we've already looked at it once by looking at the view IO, and you can actually see those digital inputs and outputs as I mentioned before. However, if we just exit out of this, to actually fully understand where these inputs and outputs are coming from, we will hit the machines again, and we'll go down to the rock crusher. This time we will hit start. When we hit start, the first thing we'll notice is that we do not have a PLC connected. So there's no PLC connected, so everything is manual motion here. And we can hit the view IO, and under this we can actually then start determining here what each input and output will do. So if we turn on the flaps advanced, you'll see these flaps back here will start operating. If we turn on the belt 6 advance, you can see that we have this operating now. We can turn on our hopper open and close. So there's our open, there's our close. So that's this hopper right here. We'll just do that again, open, and then close. Hopper 3, open, close. So all of these can then be determined exactly what's happening. Same with our analog systems right here, and then we can mimic exactly what's going to happen with our digital inputs and outputs. So it's very good to understand exactly what each input and output is doing within your system itself. And by doing that, you will help go to the next step of our programmable logic development, which is develop the logical sequence of operation. And that's step 3. Now remember, a PLC programmer must know everything about the sequence and operation of the machine before programming. So the rock crusher plant is an excellent way to learn programming. So a flowchart or sequence table is used to fully understand the process that needs to be controlled. It must answer questions like, what happens when electrical power or pneumatic air is lost? What happens when input and outputs devices fail? Do we need redundancy? Now this step is where you're going to spend most of your time. Understanding everything about the operation will save you time. It will help prevent you from continuously rewriting your PLC logic program. Knowing all of these answers of how the system is to react is vital in the development of your PLC program. Our rock crusher plant is split up into 2 different sections: the box movement on the conveyors and the rock crushers and conveyors themselves. We'll walk through the logical sequence of operation. So the first section, or where the boxes and movement around the conveyors. Okay, so we'll just move over to that section here. And this is the section that we are now looking at. So the boxes can be any position along the conveyor. So upon power up of the PLC or EasyPLC rock crusher, we will ensure that the 4 chain risers are reset. So the 4 chain risers are right here. And you can see if we were to go to chain 2 rise, you can see it rising up and rising down. That allows us to go to the next conveyor from the corner. So everything rotates clockwise in this scenario. So once we ensure that each of these boxes are in the location. So now if additional boxes are placed on the conveyor, they must be placed in the corners where we can detect their presence. If a box is detected on a conveyor chain 1 and conveyor chain 2 does not have a box and it is not risen, then conveyor chain 1 can then rise, run the chain to the left, and move that box onto the next chain. If the box is detected on conveyor chain 2 and the weigh scale sensor does not have a box or is full, then the box can raise chain 2, then chain 2 is risen. We can run the chain left, and then the conveyor and waste station can then move along. So we want to kind of take each box and rotate them clockwise and make sure that we're fully loaded on each one. So we do that for each of these corner boxes. Now the second section is basically going to be this section here, where we actually load up our box. So this is one here. So we're going to stop this once we have a full box. We're going to close this and we're going to stop this flapper. We're going to keep this operational and keep running our flappers and conveyors and keep this moving for 25 seconds. After 25 seconds, then we'll just stop that operation altogether. So that is step number 3 of our program development. And the next is step number 4, which is developing our Bricks Do More PLC program. So in order to do that, what we will do is go over to our programming software. So a programmable logic controller, or it's abbreviated PLC, it's an industrial computer that has been programmed to perform a variety of automated tasks based on various inputs and outputs. They are commonly used in manufacturing, construction, energy, distribution, and process control applications. In basic terms, the ladder logic programming language is used to instruct its function as well as operations that must be taken when a certain condition arises. Using the information from the previous step, we can now program our Bricks Do More PLC. So the first thing we'll do is set up this controller, and we do that by going into our system configuration. That's located under our project browser, or we can go to PLC and then down to system configuration. When we do that, we're going to look at the internal Ethernet port configuration, and right now we have it set for 192.168.1.11. We can configure that, and you can see here that we actually are using a static IP address. Now it's good to use a static IP address because we will know exactly where that information is coming from. So which is important that we do all the time. So we'll hit OK. And we are going to be using Modbus TCP to communicate to our EasyPLC. So we will ensure that this is enabled here under our Modbus TCP server configuration. We'll hit this button here, and you will see that this gives us our server settings. We have 4 concurrent sessions as a maximum. We have our client timeout at 60 seconds, and our TCP port number is 502, which is the default for Modbus TCP. So hit OK. So everything there looks OK. And now we'll actually look at our logic that we have for our PLC. And we'll also, if we look at our logic here, the first step we have is our startup. So we the first scan, we will set our bit C100. And C100, when it turns on, it initiates our timer. And you can see right now our PLC is in stop mode, so we're not running this logic. That's why our timer is not functioning currently. Next, what you'll see is we have our timer done. So this is under every step we must have our timer done. And we don't have our T101 done, which is our inductive switch one. So we'll leave a little extra time for it to get into that corner for us to raise it up. And when it does, and we don't have switch number 2, then we raise up chain number 1 and move it to the left. And then once we do that, then we can have our conveyor roller 1 set. And it resets it when we have inductive switch number 2. So once it gets to where the destination is on that conveyor, it turns it off. Then we have number 2, same type of logic that raises it up. We have our inductive switch here to make sure that the box is in the corner. Then we do chain 3 advance and make sure that, and then we have some additional logic for when the box is full or when the box is not full. conveyor 3, and if it's full or not full. And then we have our weigh system. So this is the weigh system reverse. So this is actually the belt on the weigh system itself. Number 3, roller 6, which is the back end, going to switch number 4, and number 6 going to back into 1. So you'll see all the logic here, and then we go into our weigh scale logic. So that first section is what we programmed and made sure that that was operational first. Then we go into our weigh scale operation, and you can see here that we actually are monitoring our weigh scale, and when it's greater than or equal to 1500, which is our maximum limit that we want to put in our box, our 15 kilograms, then what we do is we set our full box. And when it leaves that sensor on our conveyor belt, then it resets that full box, or in the first scan it will reset, because remember, we have to accommodate for when we first power up this unit. Then we have our controller of hopper number 3. We open and close our hopper door and our flaps and load it up. And if we don't have our photo cell and we don't have our box full, then we close that hopper door. And the rest is what we do is control the rest of the features, our crushers, crusher 1, and our flaps. And if after our initial, if our hopper 3 is closed for longer than 25 seconds, then what we do is we then stop all of these conditions from happening. So that is our logic to control our plant rock crusher. So next what we'll do is, now that we have our program developed, and we've looked at the setup and we know their IP address, now we can test the program in our rock crusher plant. So what we will do now is go back to our simulator and call that up. Here we go. And what we will do is we will just restart this machine right back to the original. And again, we see that it gives you the same angle right here. And we will look at the I/O drivers. And it defaults to EasyPLC. So we are going to change it to Modbus, because that's what we are communicating to. And remember, this is the part where we actually test our program. So we're going to be interfacing our PLC to our EasyPLC simulator for step 5 of our rock crusher plant. So we hit the configure button, and when we do, our Modbus driver appears, and you will see we have our TCP/IP right here, and that's the same IP address as what we saw in our Do More Designer software program. Our digital inputs and outputs, we're putting 25 inputs and 25 outputs, and we have 5 analog in and 5 analog out. Although we're only using the 1 analog out from the EasyPLC to the input of our PLC, we're going to set these anyway. The scaling factor is 100. So when we looked at the program, we actually looked for 1500. So that's why we're looking at for the 15, multiply that by 100, and we have 1500. That's why we're getting that on our analog. So once we have that set, we hit OK. Then our inputs and our outputs here are now listed. We can manually move them from here into our actual driver itself, or we can hit the driver and hit automatic assignment. When it does that, it automatically lists these inputs and outputs so that it will automatically control for us, which is a much easier way of doing it. Then what we can do is we can now hit exit and start and exit the driver. So what you'll see now is that we have connection to our PLC. And if I look at the actual hardware of the PLC, here we go right now, you'll see this is our Bricks PLC, BRX, and we are communicating through this Ethernet port to our controller and we see we have our stop switch here. It's actually stopped the plant or stopped it. So the first thing we have to do is turn this logic on. In order to do so, we can actually just flick the switch. When we do, we can see that our boxes are now moving into the assigned places. And we probably have that countdown timer waiting to then install or move over, which has just happened. Moves it into our hopper. We open the door. And remember, we can view the I/O here in order to see what's actually happening. We can actually go to our logic, and in our logic, we can now see all the inputs and outputs operation. We could also go to our PLC and look at our data view, and we can open up our data view and see our rock crusher information right here and what the weigh scale is actually currently set for, etc. We'll close that down and we can actually monitor and see how this actually performs and operate. If we look at our analog input here, we're at 5. These rocks coming up here will actually dump in and we will get some values now incrementing on our weigh scale system. So nothing happens until we actually get a box loaded. But when it does, what we can do is actually use the time frame or time speed, and we can actually speed this up a little bit. So we can go 2 times and you can see everything moves a little faster, or we can go back down to normal speed. So that is the rock crusher plant. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.